Hello all. So in the last session we have seen different types of machine learning systems. We have categorized machine learning systems into three categories: supervised, unsupervised and reinforcement learning, right? So today in the session I would cover about why machine learning is actually required and what are the problems machine learning can actually solve, and then we'll see some challenges of machine learning. Okay. So when we talk about machine learning, as we have seen an example of identifying a picture of a person out of 100 images. Okay. So when we talk about traditional programming, it is very difficult for us to identify the features of a person by writing the rules or instructions of that particular person. Okay. So there are some real-time applications like image processing, speech recognition, language translation, which does not only require traditional programming, or traditional programming methods would not solve the problem of image recognition, language translation or sales forecasting. Okay. So for this reason, where the traditional programming doesn't work, we go for machine learning. Okay. So what can actually machine, as we have seen, machine learning is all about making machine understand the data and work by itself. So for making machine understand or learn the data, we make some machine learning models, right? So we have seen supervised learning models, unsupervised learning models and reinforcement. So depending upon the data that we work on, we either choose any of the algorithms for making machine understand that particular data and solve the problem, right? So what can actually machine do by learning? Okay. So as you can see, machine reads the data and understand the patterns in the data and adjust the program accordingly. As we have told, we don't do traditional or explicit programming here in machine learning. What machine all do is understand the data, find the patterns in the data. For example, if I want to identify one person in those 100 images, okay, even if the person is appearing in different outfit or with different features, the machine would be able to identify that because the features of the person is similar. Okay. So machine would understand the patterns. Okay. Second thing, as you can see, the machine learning algorithms focuses on the development of computer programs that can teach themselves to grow and change when exposed to new data. The same thing, okay. Even if the person is looking different in all different images, okay, the machine will understand the pattern of how this person actually looks like and try to identify the person even if he is appearing in a different way. Okay. And then machine learning also enables computers to insight using iterative algorithms. Okay. So we perform different iterations in the same algorithm and try to find out the person more clearly with more patterns. Okay. And then finally, as you can see, not just machine learning along with deep learning also involve neural networks with which the deep insights of the data can be understood and more processing can be done on that particular data for getting good results. Okay. Now where is this machine learning actually used? Okay. So machine learning is used almost everywhere in our day-to-day lives. Okay. So when we use machine learning for language translation, we use machine learning for traffic prediction, for web search or recommendation engines, we use machine learning, online fraud detection, medical diagnosis, text and speech recognition, image recognition, virtual personal assistants, email filtering. There are so many different applications where machine learning is actually used. Okay. Let us discuss some applications. When we talk about traffic alerts, okay, so these days, traffic alert, we use Google Maps everywhere. So there are different ways we use Google Map for predicting the, for finding the distance or for predicting the time for reaching from one destination to another destination and so on. Okay. So all this is done by machine learning. The machine actually predicts the estimated time for you to reach from this source to the destination. It also gives us traffic alerts, right? We observe green line saying the traffic is more, orange line saying the medium traffic, and the blue line which says the clear traffic, right? So all these are the predictions which are given by the machine, okay, by understanding the patterns of the traffic. Next, product recommendation. So once we search for one product or on Amazon or Flipkart, okay, so I add them in the cart and forget about that after adding it into the cart, and then when I open an YouTube or if I open my Instagram account, I get the recommendations of that particular product, ads related to the recommendations. Okay, so the machine is understanding the pattern of my search and then it is producing the results of my search history and giving me recommendations on the social media wherever I go into. Okay, the product recommendations are another applications of machine learning. Dynamic pricing. Okay, so dynamic pricing is used everywhere. Okay, when you want to book a Uber ride or when you want to book your flight tickets. Okay, so the rate of the tickets or the price for the ride would be changed depending upon the weather conditions, depending upon the travel, depending upon the demand, right? So depending upon timings, okay, in the peak hours, in the morning and evening we have different rates, and in the noon and late different timings depending upon the demand. Okay, so there are various parameters with which the rates of the rates would be changed depending upon the factors. Okay, so this is called dynamic pricing. This is also an application of machine learning. And then virtual personal assistants, so we use Siri and Alexa everywhere, right? So for Siri and Alexa, speech recognition, speech to text conversion, understanding a language and then producing the results. Okay, so this is also an application of machine learning. Google translation. Okay, so here I say welcome to machine learning class. Okay, and I want to convert this language into some other prescribed language. Okay, so this is also a machine learning task. It is understanding what I want to do, understand the data here in the input which is in English language and convert that into the destination, source language to destination language. Okay, and then social media, face tagging suggestions. Okay, people you may know. Okay, so all these suggestions are machine learning models. Okay, sentiment analysis, we give product reviews on various e-commerce website once we shop, and then depending upon the reviews, the review would be classified into positive, negative, or neutral. Okay, we give different reviews, and based on that the products would be organized, and our next search history depends on that. Okay, so this is another important application of machine learning. Okay, now before we see some challenges in machine learning, okay, let's see some basic terminology that we use in machine learning. Okay, so when I talk about a data set or when I talk about data, we have input and output, right? So as you can see here, I have this data set where I am predicting the salary of a person depending upon some features. Okay, so here the inputs are position, experience, skill, country, city. So depending upon these various features, I am trying to predict the salary of that particular person. Okay, so these input features, these input labels are called as features, and this output value y that I am taking are labels. Okay, so here x would be position, experience, skill, country and city, which are called as features, and salary is the output parameter which is called as labels. Okay, so just remember, features are nothing but the input variables which are also called as independent variables, whereas the output variable is called as dependent variable, or we also call that as a label. Okay, now when we talk about machine learning, there are two things that we have to understand. When I want to train my machine learning model, I have to give the data, right? Now I divide this data into training data and test data. Okay, so we use training data to train the model and we use test data to test the model. This is a simple analogy to make you understand. This is, in the class we teach you 5 units and we give random one question from each unit for the exam. Okay, and test you. So teaching all the 5 units and all the concepts in the subject is all about training you. Okay, training a model, and then asking one random question from each unit is nothing but testing. Okay, so here what do you understand from this analogy? More data is used for training and less data is used for testing, right? So in the case of machine learning, when I am giving my data to the machine learning model, we give more data for training, we allocate less data for testing. There is a standard recommendation. It is not mandate, okay, but the standard ratio of dividing your training and testing is 70-30 or 80-20. 70 for training, 30 for testing, or 80 for training, 20 for testing. More you train, more the model understands the pattern in the data, and more good your accuracy of the model would be in prediction. Okay, so this is your training data and test data. Apart from this, so training data is nothing but the subset of data that is used to train the machine learning model. As you can see, 80% of the data I am using for training. Okay, so the remaining data I can use for testing. Okay, so testing and validation. Okay, so there is these two terms work together. Okay, so test data is nothing but the subset of data that is used to evaluate the performance of the model, or for testing the model, how the model works is all about your testing data. Okay, and apart from testing data, there is another intermediate subset of the data which is called as validation, which we generally used for model development to hyper tune the parameters. Okay, so in machine learning mostly we will limit ourselves to training data and test data. When you go for deep learning to validate the model performance and to fine tune the model if the performance is not as desired, we go for validation data set. For now, just understand about training and test data. Okay, so as you can see here in the images, 80% of the data can be taken for training, 20 for testing, or 70 for training, 30 for testing, or you can go for 60 for training, 40 for testing. But make sure that training data is more and testing data is less. Okay, now let's look into some challenges machine learning faces. Okay, so when I talk about challenges of machine learning, the first challenge that comes is inadequate training data. As I told you, machine understands and predicts the results depending upon the data. Okay, so if you give more data, the machine will understand the complex patterns in the data and try to predict it accurately. But if you give only less data to the machine, and when you test the machine with complicated data, the machine may not be able to give you the desired results. Okay, so when you have inadequate data, okay, when I talk about data, the data may be inadequate, the data may be noisy, okay, missing values in the data may be incorrect, the data may generalize the output. Okay, so there are many cases in which the data is available actually. Okay, so when the data is not proper, when you have missing values in the data, when you have inaccurate data, when you have incomplete data, the machine learning model fails, because machine learning models works by learning from the data. So the data that we give should be proper. Okay, so this is the major challenge which machine learning model faces. Okay, second thing is poor quality of data. Okay, even if as seen, data plays a significant role in machine learning. Okay, but it must be of good quality as well. Noisy, incomplete, inaccurate, unclean data leads to low quality results. This is another major problem of machine learning. Not just the quality, not just the quantity, but the quality of the data also has to be considered. Okay, and third important major challenge in machine learning is overfitting and underfitting. Now let us understand each of these terms in detail. Okay, now let's see what is overfitting. Okay, so I have told you about what training data and what test data is, right? Training data is the data that is a model is used for training, and the test data is used for testing that particular model. Okay, sometimes machine does well with the training data but fails to perform well on the test data. This problem is called as overfitting. Okay, it works well with the training data, but when you give a new data on the test, it fails. Okay, maybe the test data patterns may not be available in the training data. So this condition is called as overfitting. Okay, so overfitting occurs when a model learns the details or in the training data to some extent, but it impacts negatively on the test data. Okay, so the data may be too complex, or the test samples that we have given might not be available in the training data, such that the machine is not able to understand what did you ask in the test data. Okay, so this occurrence or this situation is called as overfitting. Okay, and then the next term is underfitting. Here in this case, the machine fails to work well with training data only. Okay, the machine is not able to understand the simple or the complex patterns in the training data itself. When the machine is not able to work properly on the training data, obviously it fails working with the test data. So this is called as underfitting. Okay, so underfitting occurs when a model is too simple to capture the underlying patterns in the training data itself. Okay, if this happens when the model doesn't perform well with the training data, it does not work with the test data or generalize new data as well. Okay, so this is called as underfitting. Okay, so today we have seen what is machine learning, why machine learning is actually needed, and what are the different applications of machine learning, and then we have seen what are the major challenges of machine learning. Thank you.